Welcome to the first video sessions of the Practical OpenStack series hosted at Canon.com. My name is Anton Kananuk. We are starting today with overview of the cloud technologies, but first let us introduce ourselves. If you're already following our blog or YouTube channel or LinkedIn webpage, you know that we are providing services in terms of the training, consulting in network automation. We expand our portfolio also to public cloud and automation of the public cloud or private cloud. In this video, we are focusing on the OpenStack and the some follow-up in this series. However, you could find a lot of other useful videos on our channels about networking technologies and automation, and some of our OpenStack open source projects such as PyGNMI, which is a leading Python library for managing networking devices with GNMI. We already have a number of customers who have trained at our automation training, such as Nokia, Deutsche Telekom, Barclays, Cityfiber, Yandex, and some other really big and trustful companies. If you're interested in to uplift your skills, your expertise, join the list of our students on the self-paced or in-person trainings and get started with the automation. Now, as said, we are starting something new, which is a discussion about the OpenStack. And before we will start talking about the OpenStack and why OpenStack is really needed, let's take a look into the definition of the cloud computing, because when we talk about the OpenStack, we talk about the cloud platform. One of the definition of the OpenStack is cloud operating system. But what is cloud? Why cloud is needed and all? There are a lot of hype, despite the term cloud is used really for their ages already, still a lot of hype. So let's cut it through to their simple and practical building blocks. We are living in the world of the cloud application. A lot of the services which we are using right now, they are cloud-based, starting with the most popular mail services, such as, for example, Gmail or Yahoo, or any other public services, as well as a corporate such as Outlook Online and Office.com in general. All of them are hosted somewhere, as we say, in the cloud, and you are getting access to that through the internet. A mail is just, one of the tiny pieces of the application. Almost all the applications we're using these days, they are based somewhere in the cloud. File shares, Dropbox, Google Disk, just box.com, any other SharePoint, any services that you are using. Applications for the office work, any sort of the Office 365 application, Word, Excel, PowerPoint, Visio, other things, as well as Google applications such as Google Sheet, Google Docs, or Google Slides, any other third party, Draw.io, Lucidchart, and others, and other. The variety of the application that we are used to right now, mainly in the online format, is quite huge. Collaboration area, Zoom, the one that we're using to actually record this webinar, Teams, GoToMeetings, a lot of other things. Outside of the primary, the business area, working area, mails, file shares, office collaboration, all the things can be used not only for the work, but predominantly for the work. We're having a lot of streaming platforms, Twitch, one of the example, right, where the people can stream how they work, how they game, any stuff and had an interaction, gaming subscription platforms, Steam, Blizzard, Battle.net. The number of the application you're using daily, which are cloud-based, is really huge. However, start looking under the hood, what the cloud means before we start talking about the cloud. So we need to understand where the cloud can be used. In the cloud are used to host the application, and there we start thinking, okay, any of the services that we were just mentioning above, under the hood, obviously they might be much more complicated, but in the very simplistic way could be fitting in such a diagram. We would have some entry point to our application where the traffic from your tablet, from your mobile phone, from your laptop are hitting. There will be some security stuff, virtual or physical firewall, IPS, IDS mechanism, or something that is protecting the system from the malicious attacks and allowing only legitimate traffic to go through. Obviously, the amount of these components could be high. It could be that firewall and APS are different devices or different functions. It could be that we have also anti-DDoS attack systems, DDoS protection mechanism and others. But in a simpler words, there will be something that is protecting the traffic when it is hitting the platform. Then there will be a load balancer, right? All the applications are built with the purpose of scaling so that multiple instances which are doing the same job for the same thing, like front end. If you think about the front end is a very simple term, as a function which is rendering the web page when you are trying to access, for example, Google.com. So you're receiving the response when you type the google.com into your track bar from one of their front-end servers. Then, obviously, in order to be able to spread the load between multiple servers doing the same functionality, you would have a load balancer. Again, it could be physical, it could be virtual. There are multiple ways how they could be implemented. Same story after the front end. So the front end generally providing some piece of the functionality of your application, such as rendering the web page or doing some simplistic stuff. However, or if you think about the network automation app, you hit the NSO or anything like that, you have the application which is responding to your job, but not the same application is talking further to the networking devices. So there is therefore a component which is called a backend, which is not available directly to the users, but only the internal function front end could access backend. Again, for the same purposes as scaling, and as well as from the load perspective, also for the fault tolerance to providing the redundancy, you would have a multiple instances of the backend. It could be 2, 3, 10, whatever the amount is really fitting their equipment. The load balancers could be physically the same as a front-end load balancers. It could be separated. From the logical perspective, obviously they are separated. They are separated rules, separate API addresses, and other stuff. And also somewhere your application would be relying on certain data. So thinking about the network automation app, the databases would contain their information about configuration of the networking devices or inventory and some other stuff. It could be also the operational data. So obviously the nature of the application, there might be much more levels. It could be not only front end and back end, it could be with a modern microservices framework backend consisting of multiple components rather than one monolithic thing. And further components. But if we think from the 1,000 feet point of view, this is how the application is looking like. The interesting thing, especially for the networking folks, I myself was coming from the networking background. I am double CCE, so I spent the vast majority of my professional career so far building, operating, and optimizing, improving, and automating their high scale service provided and data center networks. And I know that focus of a lot of, especially network engineering folks, so switches, routers, probably then firewalls and other stuff, whereas you don't see network here as such, right? So probably firewall, probably load balancer to a degree. However, quite often load balancer, if you think about the traditional data center department or networking department, could be even not part of the network. This brings quite an interesting thing. The network is just a glue which is providing your connectivity. It's just a commodity that needs to be able to provide the connectivity between the application building blocks. It's like an air. If there is no air, you cannot breathe, you die. But if it is air, you do not see it, it just does the job. The same story should be with the networking. So that's why we'll talk about that in a moment, but you see from the such a specific networking elements, only like a firewalls, providing security, and load balancing, providing kind of service. It brings us to quite an interesting point. If we think about this is an application at the high level, we have a security in the perimeter. Obviously, we would have security in the between. So to permitting only the legitimate traffic and flow and authentication and authorization between the front ends, back ends, and load balancers and all the bits and pieces, we would have only this is like kind of the network. And then on the other hand, in order for our application to work, we need something that is doing for us front end, back end, and database services. So if we split the whole service into multiple components, we can generally normalize almost any application down to 3 big categories. This is computing, networking, and storage. So computing component, networking component, and storage component, all 3 together, creates the whole foundation, the infrastructure for each and every service. So when you talk about the computing, what exactly do we mean? So think about your laptop. Think about the bare metal server or VM. From the computing perspective, the parameter that they have are CPU, how many cores do they have, and what are the frequency, probably some extra functionality of CPU if you start drilling down whether they support a specific set of instruction, talking about the networking and the fee, such as IPsec instruction to improve the efficiency of IPsec traffic or video optimization, and so on and so forth. And second is RAM. How many gigabytes of RAM does our computing entity have? So laptop, bare metal servers, VM, how much memory does it have in order for application to work? Each and every component of our application that we was talking so far would have both of these components, CPU and RAM. So then networking, I already mentioned, so it's like an air. It's, if it's there, you don't feel it, you just breathe with it. If there is no air, you are dying. So same story with any cloud application or any application based somewhere. If there is no network connectivity, the application simply don't work because various parts cannot talk to each other. Load balancer cannot talk to front ends cannot talk to another load balancer cannot talk to the backend, and so on and so forth. So the primary focus of the networking is to provide the connectivity between the components of the cloud as well as for the clients outside to your application. Second piece of the networking are services. So those components you have seen on the previous images, such as load balancers, firewalls, so it could be further think as DPI, QoS mechanism, and others. So something that would improve the availability and performance of the application. A third component, which was not explicitly mentioned in the previous diagram, but always like this there, is the storage. So each and every compute normally entity needs some storage, whether it is a disk where you store your application, and in this case we talk about the block storage, where we could have the physically the VM RAM and CPU allocated on one server, calling the OpenStack compute node, and storage array, or I mean certain space on the disk on another storage core on the storage node, and there is some sort of networking communication which is connecting your compute resources to the disk. I mean, we're talking a little bit more in details, but you could think about each and every compute instance need to have some storage. Your laptop has some hard disk drive or solid disk drive, right? HDD or SSD. So do any bare metal server, so do any VM. And the last but not least is an object storage. So this is a possibility for us to create a sort of like a Dropbox experience or Google Drive, where you could store certain files, images of their software or configuration files or templates or anything else shared, which can be accessible and might be needed for the operation of your networking services. So templates of the new website, the drivers, how to interact with the networking device, we talk about the automation, and others are good examples of what is stored in the object service. So as such, just repeating this, any application that exists from the infrastructure perspective, from the resources perspective, needs 3 types of resources: computing, networking, and storage. From the computing, predominantly we are talking about CPU and RAM. There might be more, but the bare minimum, there would be CPU and RAM. There will be networking, again, something that is providing connectivity for us, as well as services such as load balancing and firewalls. Again, this is a bare minimum of what networking from the infrastructure perspective for the application need to give us. And from the storage perspective, block storage as volumes for our compute resources, and object storage to store certain information that might be useful for many applications to have them working. Now, mapping all together the infrastructure sources and the application, what we have taken a look into so far, we could think that each of these components that we was mentioning just beforehand can be explained or could be existing as a number of these elements. So starting from the firewall, so despite they are providing as a functionality from a networking perspective, it can be created as a bare metal server. First of all, it could be purpose-built hardware. We put it a little bit aside as not really a cloud native approach, but it could be still physical device. It could be a VM. If you talk about the application running within the VM, or talk about the specifically networking function, and we'll talk about that more over our video series later, virtual network function, where we are virtualizing traditional networking devices such as firewall, routers, security gateways, and others. And virtualize as a meaning we are moving the function that you're executing into the VM or a container. If you create the VM, it will have certain amount of the CPU cores, right? So it would have a certain amount of the memory. It will be a certain amount of gigabytes on the disk. This certain amount varies typically per their capacity need. For example, amount of CPU and memory needed to process 1 gig of traffic would be much smaller compared, typically, again, would be much smaller compared to the amount of the resources needed to process 10 gigabytes per second of the traffic. So there is not like a direct scale. However, it solely depends on the implementation of the particular vendor. There might be direct dependencies, but normally that's would define you. You'll have at least, if we think like if you're doing the first step into the cloud, like one-to-one mapping of the physical infrastructure to the virtual one, we might have a multiple containers. So we might have at least 2 VMs, so which are acting as a HA. However, over the course of our video series, you will see different design patterns where we start with a traditional just mapping into the virtualized world, like 2N, how we call in the networking world, like 2 routers, 2 firewalls, 2 load balancers, whatnot. And then looking in more advanced scenario service function chaining, how it could be implemented with the help of the OpenStack and other things. So then, same story with the load balancer. We'd have at least 1, probably 2, probably more. Probably when we talk about the microservices and service chain with general load balancers could be implemented as an entire software function without any dedicated resources. There are different options available. Same story, if it's implemented in the VM, certain amount of the VMs, each VM has certain amount of CPU, amount of the gigabytes RAM of memory, some disk gigabytes could be like 4 CPU and then 32 gig of RAM and then 100 gigabytes of the disk. So CPU and RAM obviously coming from these computing pieces. So persistent disk is coming from the storage, block storage. And the function itself is performed the networking. However, also all these arrows, red and orange, as you see, this is basically underlying the networking function, which provide connectivity of one VM to another. So front ends, load balancers, again, backends, databases, all of the components we could quantify with the amount of resources, CPU cores, gigabytes of RAM of memory, persistent disk, depending on their performance level. We, in general, could say that, yeah, VMs is old, VMs were with us for, I don't know, 10, 15 years. Now everyone talks about the container. Well, it doesn't really matter whether we say we would like to go with the containers in order for the some compute instances, whether it's bare metal services or containers or VMs, to do some job, they still need resources. So you still would need to have some CPU, some memory, and some disk. We'll talk about that more later in our video series. We'll be discussing the Traditional, first of all, OpenStack setup, then some extended OpenStack setup, and others, where we really we'll see how all these multiple different building blocks are working together. So the last piece for our first training video would be, you might have heard a lot of different concepts already today in our video. You might have heard about them previously in your professional career, like everything is besides containers is bad, or containers is cool, but there is no secure and I still like to stick with the VM. Ultimately, it all matters what your application need, how your application is developed, and how it's going to be developed further. Each of the approaches of the development and deployment of the application has its own benefits and drawbacks, starting with the bare metal, which were originally the way how the application was developed and deployed for decades. We have normally one application, one server, big monolithic application, quite inefficient in terms of resource use, because different resources might have different resource profiles. Some applications or some parts of the application require a lot of CPU and memory, others would require heavy I/O. So therefore, block storage and the network connectivity associated with that, some would require more bandwidth per VM, or not per VM, per application, and therefore some servers would attracting more traffic and processing them. And with the time, the second like big epoch in development of the application and deployment of the application were virtual machines. They said exist with us for quite a bit. We're still heavily using them in a lot of applications these days. The idea is that within the application, you have your own operating system, which could be the same as your underlying bare metal, could be different, which allows you to deploy application is completely different guest application. Obviously, there is some penalty because you would have some administrative overhead to run the corresponding operating system inside the VM. But generally, you have also flexibility. If you have problem with the application within one VM, it doesn't affect any other VMs run on the same server. There are multiple different hypervisors available, free, open source or commercial one. In many cases, one VM was one application. However, if you talk about, if you think about the bigger application we was just discussing before, one application could be split into multiple VMs, and in fact, in quite multiple VMs, because if we implement the whole, even this simple application into the VMs, we could simply count that we have right about 12, 16 VMs. It could be even more. So, the latest trends in development of the application was microservices, containerization of the application, in theory, the most efficient resource utilization, because we still could isolate one application from another, though we don't have that huge administrative overhead in the sense of resources wasted to run its own operating system. On the other hand, the security of the container is getting more complicated topic, because if someone breaking into the VM, from the security perspective, internet facing the VM, quite often he or she would not be able to access further if obviously the security is properly implemented in the network. Whereas in the containers, almost monthly or one in a few months, we're getting the new critical vulnerability that there is a security breaches from the container, so that if there is certain CPU running under the hood or some security patches not installed, while obtaining access to a specific container, we could get access to a whole system. We put a discussion about security aside. They are very important, though. However, if you think about from the perspective of the resource placement and resource management, the containers so far being promoted as a way forward, and obviously we could see it developing and being various applications deployed in this more and more. One, though, interesting thing is when you deploy the containers, you have two options. You could deploy them directly in the bare metal services, clear, and you could deploy them also within the VM. So this approach is also quite popular these days because it gives you reasonable trade-off between the security risk and ease of management infrastructure. and abstracting the infrastructure resources in the form of VMs where we deploy containers on top. We'll talk about these multiple scenarios through our videos, but at this stage, we hope you have a more or less good understanding what cloud computing is, where basically it comes from, why it matters, because we all use cloud application, right? And what are the types of deployment or the workloads which we have in our clouds. So thank you very much for your attention. That was the first training video in Practical OpenStack series. And let's go to the second video.